Mathematical models of machine drives are derived in a uniform manner that first uses space vector description of physical variables such as voltage, current, and flux, and second transforms the space vector-based model into different frames of reference. By adopting this unified framework, it is hoped that the dynamic models of drives can be understood by a student who does not have extensive knowledge of AC machines due to derivation made in a similar process. The creation of mathematical models of AC drives is the first step in the development and implementation of control systems. In this chapter, mathematical models of machine drives are presented in a uniform way, firstly by using a space vector description of physical quantities such as voltage, current, and flux, and secondly by converting the space vector based model into different reference frames. The asynchronous machine or the induction machine is used as an example to illustrate in detail how its dynamic model is constructed. Why do we do all this? Why do we need all these mathematical transformations? In order to achieve the same level of control as DC motors, field-oriented control FOC of asynchronous machine also uses techniques such as the Park and Clarke transformation to decouple the torque and flux components of the motor. The Park and Clarke transformations are mathematical techniques that are used to transform the three-phase stator currents and voltages into two-phase currents and voltages that are aligned with the rotor-flux. By doing this, it becomes possible to decouple the torque and flux components of the motor and to control them independently using separate control loops. This makes it possible to achieve the same level of control as DC motors. In summary, the use of the Park and Clarke transformation, along with other control techniques, is an essential part of field-oriented control of induction machines. By decoupling the torque and flux components of the motor, it is possible to achieve precise control of the motor's speed and torque, which is important in applications such as robotics, electric vehicles, and industrial automation.